I hope you're all having a fine and happy and lovely day. We've done stuff with inscribed angles, we've done tangent radius relationships, we've had all kinds of exciting things, central angles, the whole nine yards. And there's yet one more thing that I want to show you. We did chords with angles yesterday. But today what I want to show you is a chord radius, it should just be chord radius relationship, but the diameter is part of the radius. So you'll see what I mean in about a second. So let me go to here to workspace and just hide that for a second. So let's put a chord on here. So if I were to sketch a chord, okay, and if I were to construct the perpendicular bisector through that chord, I want to see what happens here. So the first thing I'm going to do is I'm going to construct, hold on, how come that's not giving me an option? Oh, there it is, yeah, midpoint, okay. And then what I'm going to do is highlight that and the point, and I'm going to construct a perpendicular line through there. Isn't that interesting? Huh. I notice it, oh, look at that. I wonder if that happens for everybody. So I'm just going to do a different chord over here, and I'm going to do the same thing where if I were to construct, let me do this again, I'm going to construct a midpoint and then a perpendicular line through the midpoint. Construct perpendicular, oh my God, that goes through the center too. Get out of here. So let's see if it works for yet another one. Are you guys predicting what I'm predicting? Yeah, I think it could probably happen. So I'm going to do the same thing, construct my little midpoint, and I'm going to construct my perpendicular line through there, and voila. So what is basically happening is that it tells us that if you construct a perpendicular bisector through a chord, it's always going to pass through the center. Wow. If you construct watch this, look at me go. Where's the little perpendicular? There you are, perpendicular bisector. Right, bisector through a chord. It will always, I don't know how to spell, you guys, I'm so bad at this, always pass through the center, Wow. Okay, well, I've had issues. Always pass through the center. So I think that's what the whole point is that, whoops, my little escape button has always been loose. Okay, so I think what that's saying here is that if I just go along here and I do this, you are guaranteed that if I do something like this, if I'm passing through, it's like if this is the midpoint right here, that this piece here, whoops, what that's going to show is that first of all, we've got ourselves a right angle. That's what that perpendicular is, right? We got a little perpendicular here. Right? That's the first thing. And not only that, but we also have, make this 8, and we can go over here and make that segment, whoops, and make that segment 8. So this little piece here is going to wind up being congruent like that. And now what's cool is, my friends, is check this out, is that you can go ahead and draw in your radius, and now we've got ourselves right triangles, and here comes that Python swag and trigonometry, as we all say. So let's see if we can go ahead and do a couple problems, okay? Oh, I just realized that. Yes, now I know what I want to do. Okay, so looking at over here, these are some cute problems. I'm going to get into some juicy ones in about a second, but these are ooty cootie patootie. So again, if you look over here, AB is your chord, and if we, go through that center point, we go through the center point here, this is a perpendicular bisector, okay? Because if it's perpendicular, it's also going to bisect, which is really fabulous because it has to come from the center. So, and I'm going to change the color of this. Yeah, let's go to pink. And so in other words, I know that AP is going to be equal to AB, and I also know that QD is going to be equal to QC. So it's saying, and it's telling you that they're equal. So that's telling you that beautiful chord radius. So if PO is 8, so PO is 8. So if PO is 8, that means, well, I don't know about anything else. I have to go ahead and find out what OQ is. Oh, I didn't. Mama Schwa should have read this. You guys are probably screaming at me right now. If AB is equal to CD, that means that all 4 of those segments are equal to each other. So the distance from O to P is the same as the distance from O to Q. That was really dumb. Okay. Silly me, didn't read. Okay, so over here, you're given a bunch of stuff. You're told that AB is 6, which tells me that this is 3, and that's 3 right there. OP is 4. Okay, that's nice. CD is 8, which means this is 4, and this is 4 right over here. OQ is 3, and then ED, where the heck is ED? Oh, it's BD. Oh my God, my eyes are so bad. Is 6. And they're saying, what's the perimeter? So we had to establish that these things were, congruent to each other. So we had to break it up. So the perimeter would be, that's 3 and 4 is 7, and 3 is 10, and another 10 is 20. So your perimeter would be 20. My God, that's such an elementary question. Okay, now we're going to get down into some decent problems here. Okay, so again, here's your chord. DW is your chord. ON is your diameter. So you should automatically know that the piece from here to here is equal to the piece from there to there, and you should automatically go ahead and put your 4 right angles in there. And again, this is a radius, this is a diameter, so it's cutting the circle in half, which means the measure of arc OD. Yeah, I know they only asked us for Y, but I'm going to go to town on this, right? Because this is what I do. That Y, that OD is going to be 180 minus 136, because this is how I roll, which is 44. So this is going to be 44 degrees right here. And again, because this is true, so because this piece here is congruent to this piece here, then I can say that arc OY is also going to be 44, and his friend here is going to be 136. Now, I'm going to get a little wacky now. I'm going to go crazy. I'm going to do a little bit of a problem, or maybe what I'll do is I'll go into, no, we're going to do this now. So if you look at arc DN, this angle Don, you should all recognize is 72 degrees because it's going to be half of his intercepted arc. So this is going to be 72 degrees. And I hope you guys all realize that this entire angle here is 90. I'm going to erase that so it's like kind of out of our way. But this little angle here is 72. This angle here is 90 degrees. So this angle here is going to be it's on the eraser, is going to be 18 degrees. And then 18 degrees and this angle here are going to be complementary, so that is also going to be 72 degrees, right? Which means, and again, this is a bisector, like we're literally bisecting because we have a kite. So we got these, kite means these two sides are equal, those two sides are equal, and so forth. So we have all this beautiful congruency going on. And if Y is 44, then his inscribed angle is going to be 22. He's also going to be 22, so it all just kind of works out quite nicely. Wait a minute. Hold on a second. Did I do something wrong here? Yeah, 136. Oh my God, 136 divided by 2 is not, I know you guys are saying is not, I'm such a moron lately, is 68 degrees. The reason why I'm looking at this is that this should be 68 degrees in here, as should he, because this should be 22, and you guys should all look at this angle and say that's 22 because it's intercepting that arc there. So you guys all need to call me out on that. So, all right, so let's just hang in there because I want to try to find. I took a shot of a problem, and I want to get this problem up for us to see. Hold on, let me cancel this first and go to a fresh page. All right, so again, I'm going to go here to my pictures, modified. I think. Is it this one? Yeah, it is. Okay, perfect. Come on. Okay, you guys should know how to do this problem over here. I'm not as interested in that problem as I am this beauty right over here, okay? And it says round to the hundredths where necessary, so we're just going to put this over here. And this is a really nice problem because it's going to hone in on everything that we're doing. Okay, so get your calculators ready and all that other exciting stuff because, it's going to tap into what's going to be next. Well, okay. So again, we have the chord, we have this chord FK, and we know that if we're passing through, if it passes through the center, this is going to make 90-degree angles, and then FH is going to equal HK. Anytime you see that, all good. Bam, 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 and then make your right angles and so forth. So the other thing that I'm always going to encourage you to do, I'm going to go with a different color, is you're going to connect F to U, so you're going to connect your radii, okay, because this is a radius. If you notice, all the radii in the circle that you can name are UF, UN, UK, and, yes, UY. So those are all really important things to identify, okay? So saying that arc FYK is 94 degrees. So this entire arc here is 94 degrees. NY, let's not lose sight of that, NY is a diameter. So half of 94, right, is going to be 47. So this arc is 47 degrees. This arc is also 47 degrees. So some of the things that I'm realizing is that if arc FY is 70 degrees, then the central angle is 47 degrees. Central angle is 47 degrees. And again, if I do 94 and I subtract that from 360, I'm going to have 264, which is the measure of arc FNK, right? So this whole arc is going to be 264, but each one of them is going to be 132 degrees, 132 degrees, and so forth. So things are starting to get interesting. So we have this fabulousness over here where we're going to start finding lengths of segments. UF, find UF. Did I give you anything else? I think I might have missed something. I had to tell you something. So let's say that I told you that let's say that FK, right? Because I didn't tell you anything. Let's say that FK is equal to 12, okay? So if FK is equal to 12, that means that each one of these are 6, right? So this is going to be 6, and that is going to be 6. So I know that FH is equal to 6 because it already told me that. So now I got to go find all of my other stuff. I need to find out what UH is, what UF is, and what HY is, okay? This is a nice problem. Okay, so again, if I want to find lengths of sides, I got my angle here, my right triangle, so I can go off to the side and, do my SOHCAHTOA stuff. So this is 47 degrees. This is this guy right over here. This is 6. So this is like your FU, and then this is your H here, okay? So if I want to find out what this is, I'm going to do the sine of 47 is equal to 6 over x. If I want to find out what W is, I'm going to do the tangent of 47 degrees is equal to 6 over W. I would encourage you guys to hit pause and do this yourselves and then compare your answers with me when you're done. So if I look at this, that means that x is going to be equal to 6 divided by the sine of 47. Make sure I'm in the right mode. I am not. I'm in radians on this particular calculator. Okay, so 6 divided by the sine of 47 is 8 point. So this is equal to 8.20. And then 6 divided by the tangent of 47 is going to be equal to 5.60. If I round up, 5.60. Okay. So this is 5.60. This over here is 8.20. So if you look at UF is a radius. So that means all the radii in the circle. So this is equal to 8.2. And then we know UH is equal to 5.6. But they only asked us to find out what the length of this little piece is. And if I were to call this, say, P. I know that UY is how much, friends? How much is UY? I hope you all realize that UY and UF are both going to be 8.2. So UY equals 8.20 because it's also a radius. So if I do 8.2 minus 5.6, I'm going to get 2.6. So this is going to be equal to 2.6. So this is where you got to put those clever hats on to actually see what's what. Okay? I'm going to do one more thing, and then you guys are going to try some of these problems on your own. And boom, boom. Here we go. I think it was this one. Nope. Is it this one? Nope. Is it this one? Nope. Is it this one? Yes. Okay. Open. So if I were to ask you guys, what's wrong with this picture? Would you be able to tell me what is wrong with this picture? And if you want to hit pause and think about it, go ahead and think about it. And granted, you just literally learned about this 5 minutes ago. It's all good. And for those of you who said it doesn't pass through the center, right? This should be, in other words, should pass through the center. Okay, that's what's wrong with this picture, is the line should actually going through the center point, and it doesn't. Okay, oops, go here. So yeah, so when you have a chord radius relationship, right? If I do this over here, no matter what happens, it's coming from the radius, and if I keep going on, this will always create a perpendicular bisector. Well, you always have 90 degrees, and you'll have two things that are always going to be equal to each other. The other thing I want to allude you to, my friends, is when you see something like this, your job automatically is to connect, right? Because you know that this is true, and this is true. But your job is to draw in those radii and noticing that that's a radius, that's a radius, that's a radius, and this is a radius, okay? So I'm going to give you guys some problems, and there's going to be a phenomenal challenge that I'm going to be posing to you guys during the course of the week. I hope you guys are having a wonderful day. I'm going to be doing a live check-in on Wednesday.